Okay, we were discussing part C. So calculating the number of the moles present in 50 cm cube of 2 mole per dm cube hydrochloric acid. So for solutions, acids, alkalis, uh, or salt solution, we can use the moles equal concentration into volume. So concentration is given 2 and the volume is given 50, but that is in cm cube. So we divide by 1000 to convert into dm cube. So it will be 0.05 into 2, that will be equal to 0.1 mole. Now after getting the moles of hydrochloric acid, we have to determine the moles of magnesium carbonate. So you can see nothing is given related to magnesium carbonate. So if nothing is given related to magnesium carbonate, how we can work out the moles of magnesium carbonate if nothing is there? We have the moles of hydrochloric acid. So what we can do to get the moles of magnesium carbonate? So we can use the ratio here. So what is the ratio between magnesium carbonate and hydrochloric acid, the mole ratio? So between magnesium carbonate and hydrochloric acid, the mole ratio is 1:2. Like if there is 1 mole, it will be 2 moles of magnesium hydrochloric acid. If we have 0.1 mole, then X moles of magnesium carbonate will be there. So cross multiply. So it means 2x is equals to 0.1, but we need x. So x is equals to 0.1 divided by 2, or half of 0.1. That's equal to 0.05 will be there. Then relative formula mass. Relative formula mass means the same thing like the molecular mass, because it is showing the simplest ratio between magnesium and carbonate. That's why we call that as relative molecular formula mass. So what is the relative formula mass of magnesium carbonate? For ionic
Mole.
compound, sorry,
Mole is equal to mass in grams divided by atomic mass.
atomic or molecular, but here we have to find the relative formula mass. So how to find a relative formula mass? Relative formula mass is same as molecular mass. Like, but for ionic compound, instead of using a term like scientifically, instead of using a term molecular mass, we use the term formula mass. What is the reason why specifically for ionic compound we use this term formula mass? Because like if you was having sodium chloride, it's an ionic compound. So it does not mean you have one sodium and one chloride. What you have millions of sodium ion and chloride ion held together by a strong electrostatic attraction. But what is the simplest ratio of the ions present in the structure? So simplest ratio for the ions present in the structure, that one sodium and one chloride. That's why the formula is NaCl. So when we find the mass of this NaCl, we say a formula mass, because the molecular mass represents, it is a mass of actual number of atoms present in the structure. But this structure may have millions or trillions of sodium and chloride ion, but we are not finding the mass for the total. We are just finding the mass for their simplest ratio. That's why we use the term formula mass for ionic compounds. So when we worked out for magnesium carbonate, magnesium is 24. You can use the periodic table. So magnesium is 24 plus carbon is 12 plus oxygen is 16 multiplied by 3. So this will be 24 plus 12, 36. 36 plus 48. That's equal to 84. So the total answer is 84. So we have the moles now, and we have the molecular mass or the formula mass. Now in the question, we need a mass in gram, the last part. So the first answer was 0.1. This was 0.05, the moles of magnesium carbonate. This is a molar mass or relative molecular mass, which is 84. Calculate the mass of magnesium carbonate. So how to get the mass? The formula which relate moles and mass. Moles equal mass in gram divided by molar mass, atomic or molecular. So because it's a molecule, so relative molecular mass will be there. Moles, how many moles of magnesium carbonate are there? 0.05. Mass in gram, we don't know. And molar mass, relative molecular mass or formula mass is equals to 84. So 84 multiplied by 0.05. What's the mass in gram? That's equal to 4.2. So we will get 4.2 grams of magnesium carbonate. The unit is already written, gram, so we don't have to write that. Is it clear, this question? So first we use the formula concentration into volume. Then we use a ratio which was 1:2. Then we just use a periodic table. And then again at the last we use a formula to get the mass. In the next question, a student prepare crystals of magnesium chloride by adding an excess of magnesium carbonate. So what he did, now he's adding an excess of magnesium carbonate, like more than enough, to 50 cm cube of 2 mole per dm cube hydrochloric acid. The student filter the mixture and rinse the residue. Why does the student add an excess of magnesium carbonate? Like, what is the reason why he added more than enough? When excess is there, it's not about the faster reaction. It's about, because when it is he's using, a student is using excess of magnesium carbonate. So what is his purpose? He want all of the hydrochloric acid to react, because here we have two reactants, magnesium carbonate and hydrochloric acid. So if I use this one as an excess, then the other one will be limiting. And what is a limiting reagent, limiting reactant? Limiting reagent or limiting reactant used up completely. So what is the reason why he is using magnesium carbonate as an excess? So all of the acid will react. So make sure all of the acid reacted. Why does the student rinse the residue? No, what will be the residue? Residue will be magnesium carbonate. Why he wash magnesium carbonate? Not HCl. Because what happened? You have a container. This container is filled with HCl. Okay. Yeah, to remove the filtrate, that's right. Or to remove magnesium chloride. Because what happened? First you have HCl. What you did, you're adding excess of magnesium carbonate. When you add more than enough like magnesium carbonate, so this hydrochloric acid is used up completely. And this hydrochloric acid is now turned into magnesium chloride. And this is unreacted magnesium carbonate. So when you filter it off and rinse, like you wash the residue. So when you wash the residue, what is the purpose? To remove magnesium chloride from magnesium carbonate, or to remove the filtrate. So you can see here, to make sure all the filtrate, magnesium chloride or salt go through, or no magnesium, because what happened when you filter it off, this magnesium carbonate, the solid magnesium, unreacted magnesium carbonate may have trace of magnesium chloride solution, like some magnesium chloride solution droplets will be there. So that's why we rinse or wash with water, so that it will take out, remove all of the magnesium chloride. Is it clear? Then describe how the student would obtain a pure crystals of magnesium chloride from filtrate. So basically you have to mention the points of crystallization, heat, concentrate, cool down, but you have, it's of 3 marks. So it's crystallization will not give you, like only writing crystallization will not give you marks. So you have to explain the steps of crystallization, like heat and concentrate the solution, second mark, and then dry the crystals. Yeah, heat, concentrate, cool down, and then filter and dry the crystals. All the 3 steps of crystallization. Silver chloride, which is AgCl, it is a insoluble salt. It can be made by precipitation reaction of aqueous barium chloride with silver salt. What is meant by the term precipitate? 2 marks. So how we define a precipitate? The solid form from 2 solutions, that's right. So when solid is formed from 2 soluble salt solutions, that's known as a precipitate. As you can see here, the definition. 1 mark, a solid which is formed when 2 solutions reacted or mixed. So we need a soluble salt of a silver. As we know, name the suitable salt of a silver. All nitrates are soluble, so we can select a silver nitrate. And barium chloride plus silver nitrate. This will result in a formation of barium nitrate plus silver chloride. The equation, why it's of 3 marks, like mentioning the reactant, product, and then balancing. So barium chloride mixed with silver nitrate, 2 soluble salts are there, gives barium nitrate that will be aqueous or soluble, and silver chloride will be solid insoluble salt, which we also call precipitate. This question is about the organic chemistry. The structure 5 alkenes are given as shown. What is the journal formula of alkenes? Journal formula for alkenes. Alkenes. CnH2n plus 2 is for alkane. The journal formula, not the empirical formula. If you want any alkene, it will be CnH2n. So that's called a journal formula. If they say empirical formula, then it is CH2. What is the molecular formula of compound D, of alkene D? Molecular formula means like actual number of atoms present in the compound. How many carbon atoms are there and how many hydrogen atoms? So C5 and H10, basically it is pentene. 1, 2, 3, 4, 5 are there. If I know the carbon, I can identify hydrogen because hydrogen is twice for alkene. Predict which alkene has the highest boiling point and explain your answer. As the number of the carbon in the chain increases, the boiling point also increases. So which is having the highest number? 1, 2, 3, 4, 5, 6. So E is having 6. So answer will be E. An explanation, because it is having more electrons or greater number of particles. Or you can also mention the longest carbon chain. Increasing the number of the carbon in the chain increases the boiling point. But if branches are there, if more branches, then the boiling point decreases. So you can mention there are more carbon atoms. Why the branches, increasing the branches reduces the boiling point? Because it reduces the surface area. Like example, say if you have 4 carbon atoms in a straight chain, so they can easily overlap with another molecule. So they can have greater region where they can interact with each other. Surface area is more. But if I have same 4 carbon atoms, but in a branch, so you can see the region where these particles can interact, that reduces. The surface area of interaction reduces. So only this part can interact, but the previous one, the whole can interact with each other. Or even other way around, only 3 can interact with 3, but not 4. That's why as the number of the branches increases, the boiling point will decrease due to surface area. In the next question, which alkene A, B, C, D, or E diffuse most quickly, and explain your answer. Which will diffuse faster? A will diffuse faster, but when you mention the diffusion, you should mention the mass. So smallest mass, that's why, or smaller molecular mass, that's why it will diffuse faster. So answer is A, and because lowest relative molecular mass, so I can write MR. Not about the bonds, it's about the, not about bonds, the diffusion depends on the mass. It's not about the number of the bonds, it's dependent on the mass of the. A student added aqueous bromine. Aqueous, look, there is a difference between aqueous bromine and simple bromine. Aqueous bromine means bromine water which is orange in color. Normal bromine, a bromine liquid, it's brown in color. If they say bromine liquid is added, then it is red brown. If they say aqueous bromine means bromine dissolved in water, so it's not red brown, it is orange in color. Describe how the color, because when alkenes react, bromine is added, so alkene, it will decolorize. So what will be the color change? So it will be from orange to colorless. And what about the structure? Because when alkene react, the double bond, the same structure you will draw. The bromine is added to this structure. So you can draw the structure in the same manner, but break the double bond. As a double bond break, what happened? One bromine added to first carbon, which is having a double bond, and second bromine is added to a second carbon, which is having a double bond. So basically, addition reaction occur, and it is not necessary like you make this bromine up. Even you can make on the left hand side or the right hand side of the other side. So one bromine on right and one bromine on left. But the idea is that the two carbon which are having a double bond initially, the bond will break and the two bromine atoms are added to the structure. Two different alcohols can be produced from alkene B. This is alkene B and it could produce two different alcohol. Draw the structure of two alcohol and show all of the atoms and all the bonds. Basically what happened when alkene react with steam, alkene plus steam, it will produce alcohol. Then what is the possibility, like how the two alcohol can be formed? The OH can be added to first carbon. This is one possibility. So if OH, the double bond will break and OH is added to the first one. And hydrogen is added to the second one. This is one alcohol. And we can also say it is propanol. Why propanol? Because 3 carbon atoms and OH with the first carbon. That's why propanol. Or what is the second possibility? OH might be added to the second carbon and hydrogen added to the first carbon. So that is propan-2-ol. You can make the straight as well. It does not make difference. Basically, the structure was given in this manner. That's why I was drawing as it is. But you can also draw like this. Like this is a structure in, that's also a straight chain. So it does not make difference to a product which you draw. Hydrogen can be up or down. So when OH is added, OH can be, the double bond will break. So OH can be added to the first carbon and hydrogen added to the second carbon. So that will be, and we have to show all the bonds. This is one possibility. The second possibility, OH might be added to the second. So hydrogen added to the first one. And this will be propane-2-ol. These are the isomers. State the reagent. Reagent means the chemical which you use to do this and conditions. What is the reagent here? What chemical we use to convert this alkene into alcohol? No, not acid. This alkene reacted with which substance to produce an alcohol? So alkene is already there. Steam and alkene both are reagent, but alkene is already given. So alkene will not give you mark. The second mark is for water or steam. And what are the conditions? For this reaction, we use high temperature and phosphoric acid as a catalyst. So high temperature and the catalyst is used for this reaction. Alkene C can be converted into a polymer. What type of polymerization occur if we polymerize this alkene? Alkene, which polymerization occur for alkenes? There are two types of polymerization, addition and condensation. So addition polymerization, then state the name of polymer. Polymer for alkenes, their polymer is named after the monomer. So first we check the name of this monomer. 1, 2, 3, and 4 carbon atoms. And this is a straight chain because only 2 ends are there. So it means it's straight chain. If 4 carbon atom, what will be the prefix for 4? It will be but. That's right. And due to the double bond, that's ene. So it is butene. So this one is butene, but they're asking for polymer. So polymer are named after their monomer. So the polymer will be polybutene. For addition polymers, their polymer is named after the monomer. So if monomer is butene, the polymer will be polybutene. Then we have to draw a polymer here. So how to complete? It's of 3 marks. It's very simple. Just break the double bond, draw the same structure. Your monomer and polymer should appear like letter H. And put N. This N is having 1 mark, showing these bonds having the second mark, and drawing a single bond. That's the third mark. So whenever you draw a polymer, just break the double bond, make it into single, and just link them and put N. What is the empirical formula of the polymer? For addition polymer, the monomer and polymer both have the same empirical formula. So what will the empirical formula? What is the empirical formula of the monomer? Empirical formula means the formula which represent a simplest ratio. So it is C4 and H8 is a molecular formula. Empirical formula is CH2. So if empirical formula CH2 for monomer, for polymer also it will be CH2. So addition polymer, there the empirical formula of monomer is actually same as empirical formula of polymer, because what happened, they link with each other, but nothing, the number remains same, the ratio remain same. And you can see the weightage of organic chemistry, 19 marks, like it's about 1/4 of the whole paper marks based on this, or 25%, because the total is 80, so 20 approximately 19, which is approximately 20, so about 25% of the marks based on organic chemistry. So this was the last question related to